Welcome back, everybody. In this video, we're going to read data from a GPS unit that sends data via UART into an FT232RL chip, then to a computer via a physical USB port, but that's going to be mounted as a virtual COM port, and into a .NET program using the serial port control. This is the quickest, easiest way to get data from a circuit board in UART format into host computer software. If this sounds somewhat complicated, it's not. Keep watching, you're going to see this is by far the quickest, easiest way to do it. So before we take a look at our circuit today, let's take a quick overview of the project that we're going to do. So here we have the PMB688 GPS antenna and the PMB688 GPS unit. The PMB688 is a commonly available GPS unit. It's very economically priced, and it's pretty standard in terms of its UART communication. In terms of the PMB688 follows TTL logic, not RS-232, 4,800 bits per second, asynchronous serial, 8 data bits, no parity bit, 1 stop bit, and non-inverted. And what the PMB688 is going to do is going to stream data via UART, and we're going to stream that into the FT232RL chip. And of course, on the other end, the FT232RL chip is going to have a USB connection. And then on the other end of the USB cable, that will connect into our computer, again as a physical USB connection. However, to the computer, because of the ingenious software written in the FT232RL, that chip will appear to the computer as a virtual COM port, which means in our .NET host software, we can use the serial port control to communicate with the FT232RL and therefore to read and write to the GPS unit. So what are some advantages of doing it this way? Well, one advantage is that you don't have to write any firmware for the FT232RL board. It's already written for you by FTDI. Second advantage is that in .NET, or if you're using it in another environment, they'll probably have a similar control. In the case of .NET, we have the serial port control, which makes the host software very, very easy to write because the serial port control does most of the work. What are some disadvantages to doing it this way? Well, one disadvantage is that a virtual COM port has to be chosen by the user in the host software. That's a little bit of an inconvenience for users. Another disadvantage is that the FT232 is not available in a through-hole DIP package. So you're going to have to either purchase a breakout board with the FT232RL on it, or you could design your own surface mount board. Before we take a look at our circuit, let's take a quick look at the PMB688. This unit's GPS unit is available from a number of retailers, Parallax being one of them. That's where I got mine. Currently, I think they're out of stock at Parallax. Yeah, there we are, out of stock, but they're only $40. This is a very economical unit. I probably should mention that there is a GPS antenna internal to the unit, but really to get good reception with multiple satellites for an accurate location, I definitely would recommend spending an additional $10 and getting the external GPS antenna, which connects to the PMB688. Here's the circuit we're going to be using today. Let's take a look first at the PMB688 connector down here. The PMB688 connector has 6 pins on it, yellow, which is TX, blue, which is RX, power and ground, and then 5 and 6 are no connect. The reason that those are no connect is that the same manufacturer makes similar GPS units where pins 5 and 6 are used, but for the PMB688 they're not, so we can simply leave those unconnected. And also, we're not going to connect to pin 2 today, the receive pin. If you wanted to write commands to the PMB688, for example, you can write a command to the PMB688 to change the baud rate from the default 4,800 bits per second to something faster, but that's okay. We don't really need to do that. So we'll just leave everything how the PMB688 is set. We'll leave it at the defaults, and we're simply going to read the UART data that the PMB688 is going to stream out of the TX pin into either of our 2 breakout boards. So let's take a look at those. There are 2 common breakout boards for the FT232RL. We have the Arduino mini USB to serial adapter breakout board, Arduino part number A000014. Now this board is actually kind of a small subset of part of the circuitry of the Arduino 2009 board, but even though this has the Arduino name associated with it, this board is in fact really just a breakout board for the FT232RL. And it uses a standard size USB connector, and it comes with these 2 rows here of 4 pins each, these headers pre-soldered onto the board, so you don't have to do any soldering at all with this board. Right out of the box you connect it up and you're good to go. Our other common option I should say, there are other makes of these, but these are the 2 most common. is the SparkFun FT232RL breakout board, which is SparkFun part number BOB-00718. There's a little bit of soldering required. This board ships without headers soldered into these 2 rows of 9 pins here. So what you're going to do when you get the board is you're going to solder in your 2 rows of 9 pins headers, and then also there are 3 solder pads. On the older version of this board there's 2 solder pads. But either way, what I'd recommend is unsoldering the solder pads. In fact, by default with the newer board, the center solder pad is soldered to the 3.3 volt solder pad. What I'd recommend doing is unsoldering all the solder pads, and then if you connect up the device this way with VCC and VCC-IO to the bus of your breadboard, then the breakout board from the USB power is going to power your breadboard at 5 volts and you're good to go. So before we actually take a look at our breadboarded circuit, let's take a quick look at the availability of these boards. So if we type in Arduino A000014, and sure enough we can pretty easily find these boards. Here they are on mouse. This image is of the actually older design of this board. I don't know if they actually stock the newer one or the older one, but it doesn't really matter. Either way it will work fine. There they are, 16 bucks. They're also available on DigiKey. They tell you to call for price, but I'm sure it's pretty reasonable. And I think Jamco also stocks these too. And there we are. They want a little bit more for them, but the picture is of the newer version of the board, so any of those sources would work great. If you're interested in the SparkFun board, we simply type FT232RL breakout board. Even without including SparkFun in the search, SparkFun is the first result that pops up. And give the page just a moment to load, and here we are. So here's what the board looks like as it ships. So here's our breadboarded circuit. And at the top here we have the PMB688, and where that wire is going to is on my windowsill over here in the background a little bit. Sorry for the squeaks on my cheap tripod. That's the GPS antenna. That's about as close as I could get it to being outside without actually being outside. And now if we pan back to our circuit, so we have our PMB688, and then this is the cord going to the antenna. Here's the PMB688 connector. Then we have the Arduino FT232 breakout board, the SparkFun FT232 breakout board, our USB standard size B N connector, our USB mini B connector. And let's go ahead and connect everything up. I'll zoom in so you can get a good shot of what the board actually looks like. Hopefully that makes the wiring pretty clear. One final adjustment here. Okay. Got the volume cranked up so you'll be able to hear the doink. And there's the Arduino board going in, and now the SparkFun. And let's connect our PMB688. And there we go, and now we're all set. With the PMB688, there's a LED that blinks on the back of the board, and that's while the unit is getting its GPS fix. Depending on how long it's been since the unit was turned on last, if it was turned on more recently, it'll take less time. Once the PMB688 has enough satellites tracked that it perceives that it has a legitimate GPS location, then that light will go solid, and then you know you're good to go. So let's go ahead and take a look in the device manager in Windows for how these two boards appear. Next, let's take a quick look at the FT232RL drivers and how the FT232RL appears in the Windows Device Manager. So when you first connect up your FT232RL to your computer via USB, you're going to get a pop-up window in the center of your screen that's going to say that it's recognized the device, at least if you're using Windows 7. And then what will happen is Windows 7 will automatically go out to the internet and download the applicable FT232RL drivers and install them, and the whole process is that easy and seamless. If for some reason that does not happen, the FT232RL drivers are available on the internet. So you can simply go to this page, and then for Windows or whichever other operating system you might be using, download the applicable driver and go ahead and install it. So next, let's take a look at how the FT232RL appears in Device Manager. Just another moment here while Device Manager comes up. Okay, you'll notice currently there's no serial port. And under USB controllers, we're going to find that the FT232RL is not there. So now I'm going to go ahead and connect up both of the FT232RL devices on our breadboard. And you can see we now have COM ports. So with COM ports, COM port 1 and 2 generally have been saved for physical COM ports, for your printer or other serial device, and then Windows will start mounting virtual COM ports at COM port 3 and up. So in this case, it's mounted both FT232RL chips as one is COM 3 and one is COM 5. And the operating system is able to differentiate between the two because each FT232RL chip has a unique serial number written into it during manufacture, and therefore Windows will recognize those as separate devices. So you could have multiple FT232RL chips connected to the same computer and even accessed within the same program, and you'll be able to, the program will be, and operating system will be able to differentiate one from the other, from the third from the fourth, and so on. Also, you'll notice they appear under USB controllers down here. So now that we've taken a look at Device Manager, let's go ahead and fire up Visual Basic and start writing our host software. So we'll choose new project, Windows Forms application, and let's call it read UART data via virtual COM port. Make sure we have Windows Forms application chosen, choose OK, and that'll make our project for us. And we're going to use a pretty plain Jane looking project here. We're only going to need to add 2 controls to our form. One's going to be a text box, and the other is going to be the serial port control. So let's scroll down, and there's text box, and there's the serial port control. So let's go ahead and set our properties. So for the text box, we don't want to have to squint here, so let's set the font to 11, and we're going to display our GPS data. So to make it so our columns line up, let's pick a fixed width font. Courier News is a good choice, and then we're definitely going to set multi-line to true. We're certainly going to have more than one line of data, and then we're going to set read only to true. That way the user can highlight and copy the text in the text box but can't edit it. And then we're also going to set scroll bars to vertical. And let's go ahead and do a quick resizing here. And that looks pretty good. And now let's go ahead and set the properties for our serial port control. Actually, first let's name our text box control. Let's call that txt UART data. And then let's name our serial port control. We'll call that serial port UART data. And for the UART control, all these defaults are just fine. For the case of this particular computer, with 2 exceptions rather, for this particular computer, the 2 FT232RL chips mounted to COM port 3 and COM port 5, so we can choose either of those. It doesn't really matter. Let's go with COM port 3. And the only other default we'll need to change is baud rate, so we'll change that to 4800, which is the PMB688's default baud rate. So now we're ready to start writing our functions, and we're only going to have 4 functions in our program today. We're going to have a constructor, a destructor, a form1 resize event, and a data received event. So we can use the environment to start writing some of those functions for us. So if we choose the form and then events, and then we're going to look for the resize event, double click that, and then go back to design view for just a moment and click on the serial port UART data control and our events, and we're going to simply choose the data received event. And now we're ready to start coding. Alrighty, so now we're ready to start writing our constructor. So in Visual Basic, the syntax for that's going to be subnew. And we always want subnew to call initialize component. And then in the constructor, we can open our serial port connection. So that'll be try serial port UART data dot open. And we always want to catch that in case there's an error, that way it won't catch our program. So ex as exception, and then txt UART data.text, so we can simply dump the error message out to the big text box with this statement here, exception.message, and then we can do end try and end sub. And that's it for the constructor. Now we're ready for the destructor. I should probably clarify those with some comments here. It's the destructor, this will be the constructor, of course. Okay, so let's go ahead and write the destructor now. So for Visual Basic, you always want to use the syntax for your destructor as protected, overrides, sub finalize. And what we're going to do here is we're going to check if the serial port UART data connection is still open. Then we're simply going to close it. And then the if and then the sub. And now we're ready to write the form1 resize event. Now the idea for this event is as the form is resized, for example, if we made the form bigger out to here, we'd like to keep the text box to fill the form. So ideally we should do this in code, but just to keep this program as quick and as easy as possible, we're going to kind of do a little bit of a cheat here and put some magic numbers into our code. So what we're going to do is we're going to look at the size of the form. So for example, the width of the form here is 853. So if we do 853 minus the width of the text box, which is 828, that gives us a difference of 25 in terms of the text box is 25 pixels less wide than the form. So then we'll do the same thing for the height, which is going to be 525 minus the height of the text box, which is 472. So then our height difference is going to be 53. So now we can simply make the form resize itself, or rather the text box resize itself as follows. So in the form1 resize event, we're going to type text UART data.width equals me. That's how you refer to the form, because of course me refers to the object of the class we're in, which is the form. So that's going to be me.width minus that 25 width difference, and then we're going to do text UART data.height is assigned me.height minus the 53 difference. And that's it for the form1 resize. And now we're going to do the data received event, and again this is going to be really pretty straightforward. So we're going to do try. You always want to put the hardware I/O stuff in a try catch block, so if there's some kind of concern, if somebody kicks the cord or something, just as that function's going, it won't crash the program. So we'll do try txt UART data dot append text, and then we're going to do serial port UART data. Now there's various read functions here. There's read byte, read character, read line. the one that maybe isn't the obvious choice but seems to work the best is read existing. If you're just trying to get however much data is in the operating system's buffer for that device at that moment, it just dumps it all into the program, and that's going to work just perfectly for what we're doing. Later on we'll take a look at reading lines, but we'll save that for later on. For now we'll just do read existing to keep it simple. And then we're going to catch EX as exception again, and we really don't even need to do anything with that. And then end try. And that's going to complete our host software. So now we're ready to fire up our program. And here we are. Now these sentences here, these are called NMEA sentences, and this is indeed live data streaming from the PMB 688. And these NMEA sentences, that's National Marine Electronics Association, they all start $GP, and then there's 3 more letters signifying what the rest of the sentence means, in other words, what each of the fields are. So what you want to do is you want to look up the format for each of these sentences, and we can do that by simply going to the internet and typing NMEA commands or sentences either way. You'll pretty quickly get to this document here. And if you use a different GPS receiver, that's okay, because these NMEA sentences are pretty much an industry standard, so whichever GPS unit you're using will probably use the same format. So eventually, if we work our way down, here's a list of all the different possible formats, but here's the one that's especially of interest to us, is the sentences that start $GP and then GGA. This is going to have the general purpose GPS data we're going to be looking for. So it's going to start $GP GGA, then this field here is going to be the UTC time, it's universal time. Then next we have the latitude and longitude with our north, south, and east, west indicators, and then the position fix indicator. So that indicates, if we see table 1.4, that indicates if we don't have a fix yet, which would be a 0, versus if we have a fix, which is a 1, versus if we have a differential GPS fix, which is a 2. That's going to be even more precise. And then other data is horizontal delusion of precision. That's not especially important to us. Mean sea level altitude, that could be important in certain applications, units for altitude, and then some other information as well. So the next thing that we need to do is we need to write a program to parse this string and try and section out the... So here's the finished program to parse out the GPS data from the $GP GGA strings. And this program is a little bit lengthy to actually go through line by line, so let's just take a quick look at the demonstration of the final product, and then we can look over the code. So if we go ahead and fire the program up, we're going to select our COM port to begin. I recall from the device manager earlier that our FT232RL chips are mounted as virtual COM ports 3 and 5, so we can choose either one. Let's choose 3. And there's our GPS data. So same as before, the giant text box here is the raw data streaming in, and then up at the top here we have the parsed out data. I chose the Eastern time zone since that happens to be where I live, and then latitude and longitude, these are in full decimal degrees. And for latitude, positive indicates north, negative indicates south, and for longitude, positive indicates east, negative indicates west. That's pretty much a standard among, as far as GPS data, if you type it into any other map program or anything similar. Position fix indicators 2, indicating differential GPS. We're tracking 8 satellites, and there's our mean sea level altitude. So if we go ahead and hit the pause button here, and then let's copy and paste our latitude and longitude, then we can go ahead and open up a map program. So you can open up the map program of your choice, maybe like Google Maps, maybe like MapQuest. So if we go ahead and paste in those GPS coordinates, you could probably use any other map program if you prefer a different one. They should all pretty much work with the standard GPS coordinates. And there we go. Let's go ahead and zoom in all the way. Google Maps takes a little bit longer than MapQuest to load, but it does zoom in a little bit further. So here's MapQuest. And we'll switch to the satellite view, and sure enough, that's the apartment building that I live in. Let's go back to Google Maps, give it just another moment to load. And here's an even closer up view, and sure enough, that's the apartment building I live in, so everything's working great as far as the GPS data being tracked. So now let's take a quick look at the code that makes it all work. So in Form 1, this is pretty standard form code here. We have declare our variables, and we have constructor, destructor. In the constructor, we set the new line property of the serial port control, and we're going to set that to ASCII character 13 and then 10. That's carriage returning line feed. That's standard for NMEA sentences. And then we have our destructor, and then form 1 resize event to keep the text box mostly filling the form as it's resized. And then we have the data received event. This time, instead of the previous program where we did read existing, now we're going to do read line to get the NMEA strings one at a time. And then we're going to call parse GPS data on the string buffer that's returned from the readline function. And if that turns out to be valid, then we go ahead and update all the text boxes with the validly parsed out GPS data. And then we also have two functions here to handle when the drop down is chosen and then when the pause or resume button is clicked. And the parse function, parse for GPS data, that's in this separate module here, parse for GPS data. This function is kind of lengthy, so it's probably best not to go through it line by line, but .NET makes string processing really easy. The functions in .NET are very friendly for string processing, so you know, if you prefer, if you're interested in string processing, go ahead and download the final code from my website and have a look through it. Congratulations! You now know how to get UART data from a circuit board into host computer software via USB virtual COM port using the FT232RL chip, and also how to work with NMEA sentence GPS data